Hey guys, welcome to Satya's Neural Lab. In this video, I'm going to show you how to build a real-world Python web application using Streamlit. We'll use airline flights and turn it into a dashboard with multiple different views. So by the end of this video, we would have built a Streamlit web app, performed different types of analysis on our data, and then created a visual that responds to user input. So what we're going to use the real airline flight data. Um, we're only using 2018 to 2020, and I found this set on Kaggle. It includes flight dates, airline ID, tail number, so on and so forth. I will have the link for it down below. So now let's get started with the coding. First thing we're going to need is the dataset. I called it airline dataset.csv. And I am on VS Code for any of you guys that haven't already downloaded it. Please download this and then create a folder, put your dataset in there, and then we'll pretty much just hit new file to create the app.py. So now, first things first, we need the import statements, import Streamlit as t. For pandas as PD and for blockly dot express as PX. So we have already talked about Streamlit and our Streamlit and pandas. As for Plotly, Plotly is pretty much graph visualization. So next thing we got to do after this is we're going to configure the page. So for all intents and purposes, I'm just going to write notes here. Page configuration. So let's do that set page config page title equals or whatever you're gonna call this. We'll call this airline delay. I know layout. And then we're going to have S title. Pretty much what it does is it gives us the title for ours. And just, there we go. Airline delay analytics web app. And we do a caption. I'm going to do my name. You guys can probably do your name. But yeah. Yeah. There we have it. Um, share it. So next we want to load and prepare our data. So st cache data, def load data, df equals pandas read CSV. So what this is doing is we're reading our CSV now. Um, and yes, it has come a long way. You can see all the helpful thinks it's giving me, but some of the times it's not so accurate. So this, so next we need to convert the data. So it'd be uh, oh yeah. So the next thing we're going to do after that is create the sidebar filters as it's shown. So let's see the sidebar. We're just gonna call this filters. Okay. Then we're going to apply the filters. The way we do this is, well, first, uh, let's do filter. Just to make it easier to read. There we have all that. So next, we're going to create our tabs. We're going to analyze flight delays from multiple perspectives, and these perspectives will be temporal, deviation, network, deviation, network, then distribution, and then lastly it would be application. So now we'll just start with our temporal analysis. So uh, not any of this. Alright, terms. Mm, First, what we're doing is we're grouping the data by the flight date, and then calculating the average delay. Uh, and then we have now we're going to visualize this using a line chart, and pretty much it's almost moving the correct thing. Well, pretty much press tab and then take that and delete that part. And then average delay over time. Let's see. So there we go. So next, we're pretty much going to do the same with deviation analysis. So here we'll pretty much plot the departure delay against arrival delay, and each point will represent a flight. So uh, one, so if you can't see it, here you go. This is the deviation analysis. This is temporal analysis. So I'll just stop at the deviation analysis tab for a bit. You can pause the video. And we're pretty much just going to be doing the same thing for network analysis. But for the network analysis, the table highlights the high traffic airports that are most likely to propagate delays. So we have network analysis and so every and then you can pause this to look at all that. And last thing before the application tab would be the distribution analysis. Pretty much this is going to show us if there's extreme delays and um we'll pretty much know if this is true if there's a long tail. So uh, and then yeah, so for that. And then lastly, we're going to do the application. So that will be right here. Our terminal and new terminal. And the way we're going to run this pretty much is once it opens up, and Streamlit on. This is how our Streamlit app will look. Airline delay analytics web app. We have our average arrival delay over time. We have our deviation. Let's see, deport the delay, average delay. And then this is our network congestion. We see Atlanta, network congestion, and what we can actually do, we can go by flights. So let's say we want to go by flights. Most number of flights, 63,888. 880. And then we have 2018 and 2020 on this side. So if I just change it to 2019, the whole, and we were on distribution, but the whole graph changes. Same with deviation, went from something right here to up there. And then let's just see our application. So our highest average delay airports are ADK, STC, HDR, LCK, and SHR. And I'll just, there we go. And then just last thing, we didn't get to do this, but here is view raw data. All you would do is enter st.expander, view raw data, then st.dataframe filter df.head, and then show the 100. But yeah, other than that, you now built a Streamlit web app, and the next things you can do from here to play around with would probably be create a tab for forecasting, create a tab for the map, a geospatial map, where you can have dots, and the bigger the dot, the more delays are there. So yeah, do what you want with this. Hope you enjoyed the video. If you did, please like the video and subscribe. Once again, this is Satyos Neural Lab, and hope you had a wonderful time today.